Okay, my talk is entitled Basic XML, and it's just already said, more or less, a fluent conversation from what Uche already talked about. The call for papers for this conference had a phrase, or contained a phrase, do we need new syntax, data models, or both, or is XML fine just after 15 years? And if you've already heard by Uche, at least the data model, and maybe some things like draconian error handling from the parser is at least questionable. So we've already sang a birthday song for XML 50 years ago. We started here and we are now here. And during this 15 years, lots of specifications were standardized and developed. We have XSLT, we have XParse from version 1 to version 3. We have Xquery, we have XML schema, we have XML schema 1, we have XML schema 1.1. Ah, louder. Okay. So we're relaxing, built on top of shoulders of giants, relax and tracks. We have schematron. Everything's happened during these 15 years. But XML itself mainly stays the same. We have 5 editions of XML 1.0 and we have 2 editions of XML 1.1. And if you think about the differences between 1.0 and 1.1 and about the not so huge success about XML 1.1, then we are more or less still the same. We are still here and more or less nothing happened. So what's the reason for this? Is XML very stable? Is it very mature? And similar to what Uche already said, I want to look back in XML's history. XML has a very large heritage. The first things about XML, the first concepts, were drafted in the 60s, like the GenCode project, the text description language, which later on were combined and formed GML, the generic markup language. The name Charles Goldfarb was mentioned yesterday. And then came the 80s, and we had SGML, Standard Generalized Markup Language, as an ISO standard. And SGML was a basis as a meta-language for a large family of markup language which are more or less used today, like the TEI, like DocBook, or HTML up to version 4.01. And now we have the 90s, and in the 90s we had XML. We had HTML standardized by the W3C. We had XML created as an SGL subset, and as a subset it inherited most basic components. That means most of the stuff we are dealing right now and most of the stuff which are addressed in micro XML go back like more or less in the 60s or 70s. These basic concepts of a markup language are named like a tripod, three components by Michael Spurk, McQueen, and Klaus Huttfeld years ago, as you can see. And the 3 basic concepts of SGML and therefore of XML are the linearisation, the data model, and the constraint language. And later on they coined the metaphor of a tripod. 5 years later, Andreas Witt added another leg to this tripod, made it a quatropod. And this leg was a distinction between the level, which means the concept which you are trying to express when annotating something, and the layer, which is a serialization. If you think about microformats or feature structure grammars, like in the TEI, then you get the concept of distinction between layer and level. This distinction is one thing we need if we want to talk about generic markup, like the so-called feature structures. And if you want to, we can go even further, and we can split up the linearization into the notation, which could be inline notation, which is the usual stuff done in XML, or standoff notation. That means out-of-bound notation. And the syntax. The syntax is usually that is inherited by the meta language. In XML, we have a very clear syntax. We have elements, we have tags, and we have special characters. But if you think about non-XML-based markup languages, this distinction about notation and syntax may be feasible. Okay, if we're talking about XML, we have a data model that is more or less tree-like. Yesterday we had a discussion about if XML is, this data model is more tree or more graph. You can, of course, serialize graphs in XML as well. So let's stick with the term hierarchy. The syntax consists of elements and attributes and content, which is already said by Ubuche, and we use the special characters, angle brackets, to differentiate between markup and content. As already said, we have a notation which can be both inline and standoff, and we have a large bunch of constraint languages, like relaxing, like DTDs, like schematron, etc. And if you want to have a level or lever extraction in XML, then we have to choose a specific grammar which allows that. So XML is now 15 years old. That's a teenager. And if you already know, teenagers have problems. They test boundaries. Maybe they test boundaries of the data model. 15 years after XML's first publication, people try to cope with overlapping markup. Overlapping markup cannot be annotated inline in XML, and therefore people try to find solutions for that. Often teenagers do not behave as expected. They sometimes take different approaches or different requirements. If you think about DTD, XSD, and relaxing, if you think about deterministic content models in XML elements, then you will find that all these three implementations of constraint language behave different, a little bit different, of course. And if you're 15 and you're a teenager, you challenge traditional values, such as draconian error handling, which was already mentioned by Uche. Coming up with HTML5 and with micro-XML, we have this possibility to do not stop after the first error, but let the parsing process go on and at least present the user more errors. And of course, teenagers try to mimic others, like peer groups. For example, Jason's data model. But I won't talk about Jason right now because Eric Vandervlist's talk will be coming up. Okay, if you have a non-behaving teenager or a teenager with teenage problems, how to cope with these problems? Well, first possibility was to educate them, or at least try to educate them. That means, okay, you're nice, you're my kid, you're a nice kid, and I love you, and we find a way to cope with your limitations or your problems. That can be by either simplifying XML, like micro-XML approach, or by extending XML components without losing compatibility to XML 1.0 totally. Or we can say, start over again, get a life, go away, I get a new project, I get a new meta language, or whatever. So following this discussion, we can have two classes of approaches. The one which are compatible to teenage XML, like micro-XML and XStandoff and LMNL. And of course, more following. And we have approaches that are incompatible to teenage XML, like LMNL and FTANML. I won't talk any more longer about micro-XML because Uche did a famous or tremendous talk about micro-XML. Just stick with it that micro-XML addresses three components of markup languages of XML. That is the data model, as you've already seen. There is a clear data model in micro-XML in the spec. The syntax, there are things stripped out, like process constructions or namespaces, and the parsing, speaking of draconian error handling. Coming up next is XStandoff, and I'm glad that Uche talked so much about namespaces, because this is a format which we developed years ago and which relies on namespaces, heavily on namespaces. And I haven't found any solution which encode these information without using namespaces. So I'm glad if Uche can give me a hand on this. Okay, XStandoff is a meta language or a meta markup language that's built on top of XML. And allows multiple and overlapping annotations or overlapping hierarchies. And as the name already suggests, it uses standoff notation format. And it was developed in a project for gathering linguistically annotated data. And that means you have text, and you annotate these text by different parsers or linguistic resources, and you try to stack the output of the different resources on top of the already present primary data. And there will be a point in time when you can't stack another resource level or resource layer because you have overlapping markup. And then you have to go either the standoff way or use something else instead of XML. Okay, apart from that, XStandoff supports discontinuous elements, which are not supported in XML usually. multiple parenthood, and the differentiation between dominance and containment. If you're interested in this stuff, you should have a look at the papers by Michael Spurber McQueen and Klaus Huttfeld talking about Tex-Mex and Goddard-like features. We won't have time to go into detail here. Okay, although XStandoff is based on XML, it addresses two components. The data model, which is not more a tree, but more like a Goddard. It's a generally ordered, direct descended annotated graph. And the level layer distinction, of course. And since examples tell usually more than words, we have a simple example here. We have the simple sentence, the sun shines brighter. And we have two annotations. The one is a morpheme annotation, and another one is a syllable annotation. And as you can see here in the highlighted parts, we have overlapping here, because the morpheme ranges from B to T, and the syllable ranges from B to H. You can't combine these two annotations in line. It will be an overlapping problem. So what we do in XStandoff, we use this whole stuff above, these. Maybe you can see it's a little bit darker by now. This is all the stuff which comes from XStandoff. And this stuff relies heavily on namespaces, because this is one namespace for the meta language, and each of these annotation layers have their own namespace as well. So what we are doing, we're using both inline annotations, strip away the content, and then stack something on top of it. And I'm afraid you can't see this, or you can't read this in the back, but this is what a typical XStandoff instance looks like. We have all this stuff here in gray, which is more or less the meta language, which is the sugar or the icing on the cake or whatever. And we have this annotation, which looks a little bit like the original annotation. Instead, it uses namespaces, of course, and it has no content. And since we have no content, we have no problems with dealing with overlapping markup anymore. The content is serialized by these segments, and these segments are referenced to in the annotation layers. So this is an approach to try to extend XML limits, but otherwise remain in XML's world. That means using XML's toolkit, like XSLT, like XQuery. We use XSLT style sheets to produce this extent of markup languages instance. We use XQuery to analyze these instances. We have another style sheet, or we have two style sheets for use for visualizing differences between annotation levels and so on. And similar to that is an XML serialization of liminal. Liminal, the layout markup and annotation language, was developed 2002 by Tennision. Later on, there were some papers by Wendell Pease and GenCode. And liminal addresses even more components of XML. Liminal addresses a syntax. There is a known syntax from liminal, the sawtooth syntax. It addresses a data model, because it don't use any hierarchies, but ranges. And it addresses the validation. And liminal differs from XML in terms of the ranges, which can be overlapping. These ranges can be annotated, and annotations on the other hand, can be annotated as well, like structured annotation. Think of attributes that contain other attributes in plain XML, which is not possible in XML, of course. In contrast to XML, which uses attributes in no specific order, in liminal, annotations are ordered. And more than one annotation of the same name and range can be given, which isn't available in plain XML as well. So this is an example, simple example, of a liminal instance using the sawtooth syntax. You see here we have elements and we have ranges and annotations, and you may have an idea why this is called sawtooth syntax, because of these angle brackets here. But since this is not XML, we cannot use the XML toolkit. We cannot use XSLT, we cannot use XQuery and all this stuff. So what did Wendell Pease do? he made an XML serialization of liminal, and this is called XLMNL. And if you think about XLMNL, you see that it looks a little bit like XStandoff. We have spans depicting the ranges, and we have further on annotations which use these spans and these ranges as starting point or reference points. So what's interesting about liminal? Liminal shows some interesting extension in terms of XML's data model. Like go with hierarchies and use flat ranges. But in that way, it abandoned one of XML's data model key features, which is structuring annotation, structuring information. Another approach, which was developed by Michael K., is FTNML, which was developed during the Summer Academy. And if you want to know more about FTNML, there will be a hint later on. FTNML is a little bit like a sibling between JSON and XML, more or less. I hope I don't say too much errors now. It addresses therefore the data model of XML, the notation format. It has an own notation format and the constraint language. The data model is more or less similar to JSON, but it adds XML elements and attributes and contents, and which is nice, it supports mixed content, which JSON does not. So you can use FTNML like JSON, using more or less like JSON like arrays, or you can use FTNML like similar to XML. And you can see here that the syntax is a little bit different from XML, but nonetheless, it resembles typical XML. Up to now, there is a pass of FTNML. There is a serialization for its object model. The object model is, as already said, a little bit different from that of XML or from that of JSON. But up to now, there's no traversal language or validation language. And yesterday, I received the hint that we should wait for this year's balisage for further development of FT and FTML.
They might have to take the paper.
Maybe. Maybe. But that's a hint only. So the question is, where do we go from here? We have different development options. We can do nothing and stay within XML's realm. And as you have seen by the examples of XLMNL and XStandoff, this may be cumbersome. You will have the possibility to structure and annotate everything you want to annotate, but it may be cumbersome. But on the other hand, you will benefit further on from the XML ecosystem. We could simplify XML and could go the micro XML way, adapt its data model, and use a subset of XML. Or, of course, we can invent something totally different like FTNML or liminal, but then we may lose XML's benefits, which is quite interesting because liminal, the sawtooth syntax of liminal can be passed by XSL 2.0 by an XSLT style sheet, which was developed by Wendell Peace. So since the surrounding or the accompanying standards of XML have grown bigger and bigger and were more and more development, it is possible to don't lose the whole key benefits of XML without staying in the XML realm. Okay, if you ask me which would be the best way, I won't give an answer for that because this is up to you. But if you ask me about what would be my solution, I would like to keep some things from current XML and I would like to abandon some things. What I would like to keep from current XML is the hierarchical data model instead or in favor against liminal's ranges. I would like, of course, support for mixed content. I would like to stay more or less in the XML realm. That means using XML's toolchains. And of course, I like the powerful constraint languages that we have in XML, like relaxing or XST 1.1 or schematron. And of course, I would like to stay within powerful transformation query languages like XSLT 2.0 or 3.0 and XQuery. And on top of that, I would like to have some things added, like the support for overlapping hierarchies and discontinuous elements. And maybe one way to do this is to use a modular approach, which was already mentioned by one from the audience. If someone doesn't want to use namespaces, why don't make them optional? If someone doesn't want to use validation languages because he doesn't wants to create a schema-less language, make it optional and all this stuff. So maybe if we can go for a modular approach, that would be a most feasible way. But nonetheless, we are celebrating a birthday today. So happy birthday, XML, for your 15th birthday. And thank you for your attention.
So I wonder if this just tells us that the compromises we made for XML were good compromises, because it looks like there may be 15 ways we could get away from XML. And you've left out some that I've run into. But none of these seems to have the same size community as XML. And even within small sub-communities like non-overlapping markup, which I think those are mainly very smart people who are doing really interesting and important things, but not mainstream, businessy, big money kinds of things usually. Even in those communities, you'll have 4 or 5 different proposals. And I'm wondering if you think that we're going to get critical mass behind anything else other than XML.
I think that's the reason why we have both XML's biggest selling point and, on the other hand, biggest drawback. Because the community is so huge, everyone tries to stick with an XML, more or less. And I cannot answer the question if there are communities large enough to propose yet another meta language like the one mentioned in this talk, and that will have, or that will gain enough support to be the next XML or whatever it is called then. But I would like to raise concerns for things that could be interesting if some clever people try to standardize some sort of XML next or whatever.
And I don't think anything has to replace XML to be successful. Yep. I think that if you have a small community that has a real problem to solve, it's great to solve it however you can.
Sorry?
If you've got a problem to solve, solve it. If
Yep.
you've got a community that likes that solution, that's great.
Yeah, I would say this too.
Yes, there's a question. You suggested a modular approach with things being optional, and as has been pointed out earlier, that creates problems, because if they're optional, you've still got to do something with them. I think there's another possible approach which Uchi suggested, which is a transformation approach. In other words, if you can transform from one format to another, preferably in a lossless way so that you can transform back again, then you have the potential to get the best of both worlds.
Yeah, and that's the reason why Liminal is quite successful, or let's say it's this way. Liminal was more or less dormant between 2002 and 2004. And last year's at Balisage, NLP's shown that there is a possibility to transform liminal sawtooth syntax into well-formed and valid XML. And this is one of the reasons I think we can maybe lose, or maybe lose XML syntax a little bit, more or less, if XML's accompanying techniques like transformation language, like XSLT, are powerful like they are today. So yeah, totally yes.
Any more questions?
Have you looked into using not XML representations but RDF representations for solving the overlap problem in linguistic workflows? I mean specifically the NIF format. I'm not sure if you're aware of it.
The XStandoff format was more or less grown naturally in the project, and of course we had a look to the left and to the right, but RDF-like formats were not an option at this time, and then it was a natural way of development afterwards.